So it says, what is the mean of those pairs of shoes and what is the standard deviation? Now, obviously, everybody's pair of shoes should be pretty similar. This one, they're all 7s. Closet, all 7s in the, for shoe size. So what is the average? 7, absolutely. Did you even have to add them up, or did you know that? Okay, so now we got to decide standard deviation. Again, you can do it by hand. You can use Desmos. You can use numbers. I showed you 3 different ways yesterday to do that. Remember, it has to do with how far away numbers are from the mean. So how far away is 7 from 7? 0, and then you got to square them all. Well, 0 squared is, of course, 0. You got to add them up and divide by how many numbers you have. 0 divided by anything is 0. And then you got to take the square root of it, which is 0. Your standard deviation should be 0. All the numbers are the same. They can't get any closer than that. That's the best data you could have. Okay, next question. Caleb, would you read that one, please?
Here's it. Or,
Question 2, part A.
okay. What happens to the mean and standard deviation of the data set when the 7 is changed to a 70?
What do you think?
I think it'll go up.
Both of them?
Yeah.
Yeah. Both will increase. Mean increase, standard deviation, your numbers are going to get further apart. You're throwing a 70 in there, definitely increase. Why would the median be a better choice for the measure of center than the mean? Yes. Because there is an outlier. There'll be one number that's further away than all the other ones. Okay, question 3. Which of the following best estimates the standard deviation of points in a card game? Not the average, the standard deviation. Well, look at the numbers. We got 490, a couple 495s, 4 500s, 2 505s, 1 510. Are those all fairly close to each other? Yeah, so pretty small standard deviation. So I'm probably just going to choose the smallest answer there. You could actually figure it out and get exact, but it does say estimate. Question 4. Very similar to the warm-up from yesterday. Some of us struggled on there, but the greatest variety was what they want, is the greatest variation. So all you have to do is look at the MAD and the IQR. The Japanese restaurant had the biggest MAD and the IQR. That means the biggest variety of prices on their menu. That's all you had to mention. Again, here, which one shows the greater variability? Same type of question as the warm-up from yesterday. A or B? Why? Yeah, you just look at the MAD. Greater MAD, bigger spread of numbers. So set B, bigger MAD. What differences would you expect to see when comparing dot plots? So if you were to graph those two or see the dot plot, this set looks like they're certainly bigger numbers, but they're closer together. So set A, the average is 43, so bigger numbers, and they are closer together. Dots would be closer because the MAD is smaller. Data set B, mean is 12.8, so that's smaller numbers. And dots would be spread out a bit. Certainly further than A. Question 5. When would the mean and median be about the same? Uniform. Symmetric. Bell-shaped. The symmetric ones, the exact opposite of the question we did yesterday. Next one, what is the IQR?
7
Remember, IQR is Q3 minus Q1. 7 is correct. 14 minus 7. Question number 7. I did not do this one. Are you confident in your mean? Without me looking it up. What do you got for average? 18.5. Anybody confirm or deny that? Yes? Got a label? Cans. How about the median? What's that? 31. I mean, there's only one number bigger than 31, so I'm guessing the mean's gonna be less than that. 16? Yes? Did you put them in number order?
Oh, yeah, I
Okay.
Is there even
Gotta put them in number order to do median.
well, I did, but like, I looked at the numbers below it. Never mind.
Yeah, it's 16.
Yeah.
Eliminate the greatest value. Explain how the measures would change.
Both of them go down.
Both the mean and the median would decrease. That is correct.